right, hello and welcome to lesson 15C. Today we're still going to be doing two-step equations, but really the only difference is we'll have some decimals today. So students will be able to solve two-step equations, students will be able to explain the properties. But remember, we do have these three steps. Step number one, draw the line of equality so you can see the two sides. Step two, circle the variable so you can see where it is. And then step three, use inverse operations. So here's some other things to remember. You want to get the variable on one side of the equation by itself. We always perform the same operation on both sides of an equation. Remember, those were called the properties of equality. Whatever you do to one side, you have to do to the other to keep everything equal. Remember, number three, to undo an operation, perform its inverse operation to both sides. Adding and subtracting are inverses, multiplication, division are inverses. And if you also want to think about it, remember, please excuse my dear Aunt Sally is the order of operations in general. The inverse of that is Sally Aunt, dear my, excuse please. In other words, we're working backwards. So instead of PEMDAS, it's SADMEP. So we generally want to get rid of adding and subtracting first, then get rid of multiplying and dividing. Then if we had exponents, we would get rid of those, and then finally parentheses at the end. So we're literally doing our order of operations in reverse when we're going backwards. Remember to show all steps, and the easiest, like I was saying, is addition and subtraction. In other words, we're getting rid of the constants and then the coefficients. Always get rid of the constants first and then the coefficients. So what that means, let's look at number one. I'm going to draw my line so I can see the two sides separately. I'm going to circle where the variable is so I can see what's being done to it. And I see that this C is being multiplied by -5, and then they're subtracting 23.3. That's what's happening here. In other words, I'm going to get rid of the constant first and then get rid of the coefficient, if you remember those words. So the constant I'm going to get rid of is a -23.3. To get rid of that, I'm going to add it back in. 23.3, because that will make this a 0. That's what we want to have happen. Whatever we do to one side, we will do to the other. So add 23.3 if you can. Try to line up those decimals so you can work that out. And I'm going to bring down what I have left. Be careful here. We do have a -5c left over. That negative symbol, that minus, stays with the 5. So I'm going to bring down -5c is equal to, well, let's see what we get here. 2 plus 3 is 5. Bring down the decimal. So 9 plus 3 is 12. Carry the 1. And 2 plus 1 is 3. So we get 32.5. All right, so now I'm going to circle my variable again, get rid of this coefficient. Remember, that means it's being multiplied by -5. So to undo that multiplication, I'm going to divide both sides by -5. That'll cancel out to a +1. All I'll have left is C, and that's where I have some work to do. I do see a positive divided by a negative, so I will write the negative symbol first before I do anything else so that I don't forget it at the end. So this one, remember, top dog in the doghouse, 32.5 is going to be divided by 5. Remember to show all your work. How many 5s can I take out of 32? Well, that would be 6. That would give me 30. I'd have 2 left over. I'm going to bring up the decimal. Bring down the 5. How many 5s can I take out of 25? Well, that would be 5. That gives me exactly 25. I have nothing left over, and so that would be my answer. Thank goodness I wrote that negative symbol first so we don't forget it's actually -6.5. All right, so I'm saying that's my answer, but remember, we have to check our work. So let's write it down. That means -23.3 minus 5 times, instead of C, I'm going to write -6.5. I'm going to write my answer. And that should equal 9.2. All right, so now we follow our regular order of operations. Remember, subtraction really means add the opposite, so I'm going to write it like that. And I see I need to do that multiplication first. I'm going to bring down my -23.3. I'll bring down the plus, but I've got to work this out. And it's a negative times a negative, which tells me it will equal a positive number right there. So let's work that out. 6.5 times 5. 5 times 5 is 25. 5 times 6 is 30, plus 2 is 32. One swoosh, which means this is going to be positive 32.5. and hopefully it all comes out equal to 9.2. All right, do I have more positives or more negatives? Well, I have more positives. So how do I figure out how many more? Remember, we subtract. We'll do that in the side workspace up here. So 32.5 was what I had more of, and then I'll subtract what I had less of, the negatives, 23.3. 5 minus 3 is 2, bring down the decimal. Let's borrow. 12 minus 3 is 9, and 2 minus 2 is nothing, and so I get positive 9.2, and yay, it came equal to the other side. So that checks out. Our answer was correct. C really was negative 6.5. All right, that's what we're doing today. Let's try a couple more. On to the back. Draw the line. Circle the variable. What are they doing to this variable? They're dividing it by 1.2 and then adding 3.4. The last thing they did was add the 3.4, so that's the first thing I'll get rid of. I'll subtract it back out. So minus 3.4 on both sides. All right, I'm going to bring down what I have left. X over 1.2 will be equal to, let's do the subtraction. 6 minus 4 is 2. Bring down the decimal. And 7 minus 3 is 4. All right, so what this tells me is they took X, they divided it by 1.2, and they got 4.2. So to undo this division, I will multiply both sides by 1.2. By 1.2. 1.2 over 1.2 cancels out to a 1. So all I'll have left is X, which is what I want, but I've got to do that multiplication over here to the side. 4.2 times 1.2. 2 times 2 is 4. 2 times 4 is 8. Placeholder. Now 1 times 2 is 2. 1 times 4 is 4. Add those up. We have 4 and 10 carry the 1 and 5. And then I need to know where to place my decimals, so I count my swooshes. 1 place, and 1 place means 2 places. So that means X should equal 5.04. So I'm saying that's my answer. Now we have to check. I'm going to replace the X with 5.04. We'll divide it by 1.2, then add 3.4, and hope our answer comes out to 7.6. All right, over here now. This is the first step. I need to get this divided. Remember, I can't divide by a decimal, so swoosh and swoosh. So that means inside the house, I would have 50.4. Outside the house, I would just have 12. Well, how many 12s can I take out of 50? I could take out 4. That would be 48. I would have 2 left over. Bring up the decimal, bring down the 4. How many 12s can I take out of 24? 2. That gives me exactly 24, and I have nothing left over. So that means this little division statement would equal 4.2. I still need to add the 3.4, and I'm hoping it comes out to 7.6. Well, let's think. 4.2 plus 3.4. Again, we want to use our little side workspace here. 4.2 plus 3.4. Lining up those decimals. 4 and 2 is 6. Bring down the decimal. 4 and 3 is 7. So I get 7.6 is equal to 7.6. Yay! It came out correct. So that tells me my answer here, 5.04, is correct. Let's try another one. Draw the line. Circle the variable. This means they were multiplying n by negative 0.6. Then they added 2, and they got 1.22. So the last thing they did was add 2, so the first thing I'll get rid of is that 2 by subtracting it. I'm going to subtract 2 from both sides. This will cancel out to 0. I'll bring down what I have left. Negative 0.6 n is equal to, well, let's work this out. Do I have more positive or more negative? Well, to check, I'm going to make the decimals match. What do I have more of? 1.22 or negative 2.00? If these were dollar amounts, it'd be easy to see. You definitely have more negatives. But let's check and see how many more. So I'm going to take what I have more of, 2.00, and subtract what I have less of, 1.22. We need to borrow and borrow and borrow. So we get 10 minus 2 is 8, 9 minus 2 is 7. Bring down the decimal, and that's a 0. So I would get negative 0.78. Okay, this variable is not by itself yet. It's still being multiplied by negative 0.6. So if they multiplied, I will divide both sides by negative 0.6. And let's see what happens. Negative over a negative is a positive. That would be 1. So I get positive 1n, which is what I wanted, equals. And this is going to come out positive also, but now we need to do that division. Remember, I can't divide by a decimal, so I move it. So this will be 7.8 on the inside. And on the outside, it'll just be 6. Well, how many 6's can I take out of 7? 1. That gives me 6. I have 1 left over. Bring up the decimal, bring down the 8. And how many 6's can I take out of 18? 3. That works out perfectly. Yay. All right, so that means my answer to that division statement would be 1.3. All right, I'm saying that's the answer, but remember we need to check. I'll replace the n with a 1.3. So that means I should be able to take negative 0.6, multiply it by 1.3, add 2, and end up at 1.22. Let's hope that works. All right, so what I need to do first here is the multiplication. So I need to multiply 1.3 times 0.6. 6 times 3 is 18. 6 times 1 is 6, plus 1 is 7. Swoosh, 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 swoosh. So that decimal is going to go in front. So we would have negative 0.78 plus 2, and hopefully that'll come out equal to 1.22. Now again, do I have more positives or more negatives? Well, I have more positives this time, and so I'm going to write that number first. In my side work up here, we're really using the side workspace today, I'm going to write 2.00 and then subtract 0.78. Let's see what happens. We need to borrow, and there we go. So 10 minus 8 is 2, 9 minus 7 is 2, bring down the decimal, and 1 minus nothing is 1. And so I get positive 1.22, which is equal to positive 1.22. Yay, that worked. Our answer was correct and really was 1.3. All right, one more just so you could see what it looks like when it's a little bit mixed up. Let's draw the line, circle the variable. This time they're multiplying this variable by 1/5 and then adding 6.3. So the first thing I want to get rid of is this 6.3, the constant. So let's subtract it from both sides. Minus 6.3. Well, let's think. 8 minus 3 is 5. Bring down the decimal. 9 minus 6 is 3. So we get 3.5 is equal to, these are 0, and I still have 1/5 times n. Well, remember, 1/5 times n means I really want to divide both sides. Divide by 1/5. I'm going to write it this way. Divide by 1/5. All right, so that looks a little funky. This looks a little weird. So instead of writing it as 1/5, let's write that as a decimal. Let's change that 1/5 to a decimal because I don't like the way that looks when it's all different types of numbers. All right, so that means I'm going to divide top dog in the doghouse. That'd be 0.0. And how many 5s can I take out of 10? Well, that would be 2. And so I could rewrite this as 0.2. Let's work it out that way. 0.2. That way I can see I'm multiplying by 0.2. So to undo that, I will divide both sides by 0.2. That means my m would be by itself. And swoosh, swoosh, can't divide by a decimal, so that would really be 35 divided by 2. I could take out 1 2 from 3, have 1 left over. How many 2's can I take out of 15? Well, 7. I'd still have 1 left over, so I'd bring down that 0. And how many 2's can I take out of 10? Well, 5. All right, so that means I would get 17.5 as my m. Now, I'm not going to have time to check that for you, but remember, we should always be checking our work. Try the exit ticket after this. It's a little bit more work today, but I think you can do it. Yay, math!